Thanks for this opportunity. And once again, good afternoon, good morning to everybody attending the session. And in today's session, really we'll focus on the achievements, the key updates that came from the targets we set. And I'll be co-presenting this with Victor and Max. And we'll actually just make sure that we can get much of what we do contained within a short space of time. Just to reiterate, for those that might be maybe listening to this for the first time, as the code quality and security workstream, we're one of the 11 workstreams on Moja Loop and focusing specifically on the overall responsibilities of improving the system trust. Then in there, we look at both functional as well as non-functional requirements, and we work alongside with other team members, the core team, the work streams, as well as the governance committees to really strive towards the common goal on a shared responsibility model. There is much that gets built standard in the functionality, and for that, we're going to showcase how we can also contribute over and above things that are built inside functionality with the review that we did for the PSP and as well as for the portals for onboarding. And in terms of our approach, we look at the standard controls and the baselines that are actually existing in the payment fields, and we actually take some of those and implement them on the core switch code as reference implementation. And then I'll actually detail that a little bit when it comes to our documentation, the new structure for documentation that we have. And we recently introduced the risk-centric view to this, wherein we, from time to time, we select key areas of the Moja Loop API, and we perform rigorous threat and risk assessment to see that as an additional way of prioritizing specific security requirements. And in terms of what we have achieved so far, we started with this as a focus program from the beginning. And in PIA 8, that's where we took kind of like a special focus with the formation of the CQS workstream. And we looked at all what was done previously, and we consolidated the base. And from PIA 9, we actually started a new journey, wherein alongside with the objectives of phase 4, we looked at where we can optimize and consolidate and improve going forward. There's a lot that has been achieved. Let's actually just give a quick high-level summary of what we have. Just to quickly move into this PI specifically. So what we've actually done, just for simplicity, is really to break down our work into various epics. The epics you see is really what we actually use to organize the different sets of work that we do. And we have what you call PI epic objectives, which really spans across multiple PI, more like on an initiative basis. And the PI objectives specific to PI 11 is really the targets that we're actually going to be undertaking from PI to PI. And specific to this PI, those are the targets that we've actually put ourselves and against all the different epics. And one might ask us to, up until this point in time, what is the source of our, PI objectives as well as the epics? So we actually get a lot of interactions, amongst a lot of team members. And from a product development perspective, we interact with anybody with a very specific need from a use case perspective, and Mila has actually taken advantage of that in most cases. And we also do our own gap analysis to see where are the areas that needs attention, in preparation of the objectives of the phase 4 of the project. So we actually do that internally amongst ourselves. We expanded a little bit to everybody who's interested in contributing. And also very important, we from time to time get the requests from implementers such as Mowali and Tips, and also we get the requests from the community contributors to look at specific areas of the API. So that's actually in a nutshell where we source specifically the epics as well as the objective that we pick PI to PI. There are 3 more epics that we have, and that we don't have the objectives for this PI, but you'll see it as time goes on. We will be bringing them on a PI to PI basis. So quickly moving into I'll be covering all the kind of like the epics that we have now, and we'll divide this presentation into three. So Victor will cover the functionality support as well as the data protection, and Max later on will close with the cryptographic processing. So I'll cover the first four, and for those, I'll actually keep them at a very high level so that we can be within the short space of time that we have. Okay, the first one is really around the DevSecOps tools integration that we have actually started with from the beginning. And this epic is really more a maintenance and enhancement exercise, wherein from time to time we look at what we have and we perform regular patch update. We look at the dependencies alerts that we have, and as well as running the ongoing kind of like an NPM scan tools for vulnerabilities as well as for license check. So that's actually something that we do kind of like regularly once a month, or if there's anything that has been flagged from the alerts, we'll actually, jump in and actually address that. Lewis is actually the primary person looking at all this. And in terms of the enhancements in this space, we have actually had a target of creating a simplified dashboard for all the alerts, but we couldn't actually move it to the next phase. So we had a kind of like a slight dependency on an environment wherein we can test this, and that will actually be solved in the next PI, wherein we are now in the process of actually putting together a business case as well as a design to have a CQS specific test environment for us to test things like this. And also with regards to the backlog, we have been welcoming lots of suggestions around some of the small adjustments that we can do, mostly community driven, and we've actually just put part of the backlog. And much of this will now be able to be kind of like addressed with the existence of the testing lab. So that is in a nutshell on the DevSecOps. Moving on to the standards baselining, we started this about in PI 10 with the two standards that we felt that at this point in time, there might be the most relevance to, the phase that we're at as Mowali, and we have actually completed those, fully, across the two PI. And what we have really is kind of like a very good view of how we're performing against the PCI DSS, and focusing mainly on those aspects of the PCI DSS that doesn't involve cut data, because essentially we don't have any existence of cut data within the switch itself, but up until the LPS adapter, there might be a DFSP or a switch operator that might have a need to worry much about aspects of this. And in there, we have actually clearly developed a responsibility matrix that clearly segregates what the OSS core team can address, and it is addressable, and also what we expect as a hub operation related function in there, because there's a lot of kind of like general IT environmental stuff involved in there. And very important, we actually took advantage of that to correlate the cryptographic requirements of PCI DSS with those of the cryptographic processing module design that is currently underway, just to ensure that whenever the switch needs to prepare itself for its journey to interface with the PCI DSS compliant environment, we will be on par with the expectation of the standard. So Max has actually done a very good work in there to ensure that all the necessary FIPS levels will actually be factored into the design of the CPM. And moving on to GDPR, we actually looked at it broadly because of some of the queries from our implementers. And what we actually came down with is really to define what we see as the addressable scope for us from a switch perspective, because much of that has issues that actually has to do with addressing of the operations of a switch to preserve privacy of the information. So we picked up one or two areas in there, and also we looked at it from a standard switch P2P transfer as to what are the PIA pieces of information that we're handling, and how best we can actually protect that. And based on those findings as well, we look at what are the current protection measures, and we identify the gaps that are part of what Victor will talk about in the protection epic. So we pretty much came to the conclusion on these two standards. And the next phase is really to look at what will be strategic for us to undertake next, whether will it be SOC Type 1 or ISO 27000 or NIST Cybersecurity Framework. So that will actually leave it to anybody to make a suggestion on what is best and relevant for us to undertake. Moving on to the area wherein this was actually a specific request from Mowali to see how best we can help them fast track their GDPR initiative. In here, we looked at all the different areas of GDPR, and we picked up the data protection impact assessment as the most relevant for us to play impact on their implementation. In there, what the DPIA actually involved is really to help identify the PII information. So it's a simple framework that they're saying for the people to be able to know the exact scope of the GDPR compliance. This is actually the first step, wherein we help identify the PI pieces. And for all those identified PI pieces, we look at the purpose of processing it as to what are the reasons why each party is involved in the switch ecosystem needs to have access to that information. Also to map out, in essence, who has access to that PI data and ascertain all the protection measures that are planned for that specific piece of information, and go on to really determine when will that piece of PI information be retained according to policy. So this actually gives you a quick roundabout of what we have actually done for Mowali and breaking it down per process. So we looked at P2P transfer, same currency, P2P transfer with Forex, as well as settlement as the first key processes that Mowali is currently concerned with. And for each of those areas, we looked at what are the reasons for processing that data, and also a little bit of the controls that are in place in there. And the overall findings that we actually got around this is they're pretty much covered in terms of the tools and controls available for them to be able to secure that PI information. So it's just the resultant architecture that they put down, and also the policies around data retention that they need to look at. And one of the things that we really mentioned to them around the data retention policy is really the need to balance in between other regulations as well as the GDPR, because GDPR actually has a what you call the right to be forgotten clause. And what we actually conscientize here is in fulfilling that the right to be forgotten clause, they shouldn't resort in deleting the data completely, because that will actually impact on other regulations that they might have. And also it will actually prevent further historical analysis of that data for any other exercise. If you want to have a historical view of who's using the switch, or you want to just perform a further analytics to see how you can serve your customer better. So it's actually much more critical for the data to be preserved, and while ensuring that it is actually used carefully in cases wherein somebody has invoked the right to be forgotten clause. That in a nutshell is actually what we delivered back to Mowali as a contribution from Mojaloop to help them on their GDPR initiative. Moving on to the documentation epic. This is actually one of the the thorny area we had, wherein from time to time we have errand requests for specific aspects of the security part of the switch. So what I've decided to do, together working with the team, is to put together a framework which we will use in the existing documentation repository, which is based on Gitbook. So what we're going to do is to have these three dissections of a view of our documentation, wherein the first one is really around program management, that is targeting the business leadership or governance view for anybody who's really interested in an overall initiative, overall programs that we take, and what are the risk management measures that we consider, and also as well as the compliance and baselining standard. They can actually quickly go to that specific section, and there will be relevant information that will be for them to review. And the standard and the guideline section is really the start of the technical aspects of this, wherein the target is more like the solution architecture view, as well as the software and the infrastructure architecture type. And in there is really a list of standards and guidelines that we have actually defined in support of the operations of the API. And not all of that has been implemented. And from the standard and guideline, all what is being implemented is reflected in the reference implementation. So moving into the reference implementation, we take from the standard and guideline, we reflect exactly what we have actually applied onto the API, so that when the adopters comes in, they can know exactly what they find standard on the API, and also what they need to build over and above, the standard control we have, and they can reference in the guidelines and the standards that we have actually defined. And with that, we'll be able to have very quick communications with anybody querying. And additional to that, we can develop a frequently asked questions. And for that, I thought of maybe, taking this to the TGB and sending a set of, proposed questions at a very high level, that we can actually put and say, from our experience, this is what people will come in and actually ask us about, and we can actually put it as together with the documentation. And yeah, with that, I will, close it here and give an opportunity to Victor to take us through the next two sections of the updates. Over to you, Victor.
Yes, thank you so much, Godfrey, for that elaborate presentation. My name is Victor Akidiva, and I work for Modusbox as a security architect, and I support the Mojaloop community initiative through the CQS initiative, looking at best practices for a secure and compliant deployment of a Mojaloop switch. Now, as Godfrey has highlighted earlier, we are guided by global best practice standards, and our work basically involves trying to identify worst case scenarios from a technical and operational perspective, focusing on cybersecurity principles, and trying to propose mitigations that should be put in place either at design or at runtime, depending on what stage of maturity the Mojaloop development is at. So I'm going to be talking to us about some of the non-functional support areas that we've been looking at, as Godfrey highlighted. Specifically, I will be touching on the PISP design as well as the portals security design, which we were able to review using the STRIDE security analysis methodology that I will touch on. So if you could move to the next slide, Godfrey, please. So what we're seeing here is the PISP data flow diagram, and Lewis will talk about the PISP process later on. It is essentially integrating Mojaloop with the third-party PISP merchants to allow customers to make payments for goods and or services. So this depicts our understanding of what exactly could be happening within the process. And based on this, we were able to design a STRIDE report that should be able to guide the PISP design process on what areas could go wrong and how they can be able to mitigate the process. So in a nutshell, the STRIDE process essentially, it's a methodology that does threat analysis. Just go back a bit. It's a methodology that allows us to do threat analysis, which allows characterizing of threats within an application. And this includes the assets, looking at it from an adversary position, and looking at the origin in terms of what could go wrong, what are we building, what are we going to do about the issues that could go wrong within our design? And have we already done an acceptable job in terms of best practices around confidentiality, integrity, and availability? And if there's anything missing, what are we going to do about it? Now, STRIDE is an acronym that stands for 5 threat areas that could affect any application, not just Mojaloop. This includes spoofing, where you try to mimic a user. Tampering, where data can be interfered with during creation, process, transit, and or storage. Repudiation, where someone can claim they are not the originator or processor of a transaction. Then we also have information disclosure risks, which will touch on what Godfrey talked about, GDPR, where data protection is becoming and privacy is becoming really critical in terms of service providers out there globally. And then we also have denial of service, the D, which talks about service unavailability. And then finally, elevation of privilege, which is always the target of any attacker. They would want to either become an administrator in your system or gain full credentials of the user and push transactions as them. So in summary, quickly, the process involved identifying of assets and access points. As you can see in the diagram, we tried to have discussions with the team and document each of the possible access points and data points within the process of linking and transaction. And then we ask ourselves, what are some of the trust levels that we expect to exist within this area? Who should be accessing what, and what controls should be in place? Then based on that information, we developed this data flow diagram. And from the diagram, we started identifying any potential threats in terms of authentication, authorization, privacy issues, audit, and logging. Then finally, we'll classify any threats identified based on the impact to the process under review, as well as severity. And then we have discussions with the various teams in terms of a mitigation plan. And this will involve either changing the design, adding additional components, or if necessary, seeking sponsor support for those risks that maybe do not have a direct mitigant. Some risks actually may involve going to the insurance. Now, this process is going to link back to what Sam had shown earlier in terms of the overall modular loop release process, and is meant to be a cyclic engagement between security team and the development teams, so that we ensure we have a shift left strategy with security being part of the process. So from this diagram, next slide, please. From this diagram, we were able to develop a STRIDE summary, basically identifying, based on the STRIDE process, what are some of the areas that could go wrong within the linking process. And as we can see here, the areas with the X are areas where we felt there was a possibility of a risk, and we are in discussions in terms of mitigations around it. In summary, the key issue that we found was that it is possible for the PISP to go rogue and conduct a man-in-the-middle attack on the linking process. And this would involve gathering of information which would interfere with the privacy issues, as well as also potentially mimicking the user and attempting to conduct the linking process on behalf of an unsuspecting user. Now, you see from the pre-linking process, there's a possibility of spoofing and tampering. And the discovery process also has spoofing and tampering risk. Again, here we're just talking about a rogue element within the PISP attempting to mimic a user. When it comes to the next steps, from requesting consent to credential registration, there are additional risks that come up simply because of two things. And that is because the PISP has a possibility of intercepting all the information being generated by the user, except for the authentication via OTP, which could be done via SMS. So all the other processes will, in one way or another, go through the PISP, which may expose some risk of tampering. However, this is mitigated largely due to the fact that all the transactions are signed and they are verified by each party before processing. So the linking process could be spoofed by a rogue DFSP. It may also be possible for the rogue PISP to simulate a user and attempt end-to-end credential registration. Our main recommendation here is, if it's possible, we have the OTP process almost to be mandatory for the user, such that they are able to have one validation process that bypasses the PISP. Next, when we're looking at this in summary, I think we can skip this because I've already touched on it in the previous slide. Next was the transfer process. Again, we were looking at it based on the diagram above, and the transaction process follows the existing modular loop transaction process. We are happy to say we were largely happy with the controls that have been proposed within the design, and the only risks that were there were minimal risks around spoofing, again, where a rogue PISP may attempt to mimic a user, and information disclosure, where enumeration of user details, this being email, mobile number, and other personal information, again, could be done by the rogue PISP. One of the things we noted here is that there is a private key that is generated as part of the linking process, and the private key is the cornerstone of security within the transaction process. This private key is used to sign the FIDO challenge that is sent during the transaction process. Now, the risk here is that the FIDO key is stored on the user's mobile device, and it's the same mobile device where the PISP's mobile application will sit. Therefore, it will be very imperative that we restrict the rights that the PISP's mobile application will have on the user device, such that they should not be able to access the private key. Now, this forms our next steps in terms of what we need to research on. as to whether the private key can be accessible by the PISP's application within the user device. Now here we note that on iOS and Android, they have various security implementations with regards to private keys. So we are going to explore how that can be harnessed and give recommendations to the community as to best practices for the PISPs to design their mobile app to protect that private key. Because once it is compromised, then anyone who has that private key can transact and sign transactions as the user. In summary, we want to look at the security of the mobile device. Lewis is designing a sample mobile application, and this will form a part of our testing. We will try and see whether it is possible for the PISP application to reach the private key. We will look at the implementations of iOS and Android. And based on that, we can be able to come back to the community and tell them how we were able to fare on. And then we also recommend that the PISP and DFSP invest in device fingerprinting technology so that they're able to actually, upon the linking process, lock down the device that the user has. In the event the device changes, then they should be able to note that and apply further security authentication to ensure that the person holding the device is actually the user who conducted the linking process and is now trying to transact. Next. The second review that we did as part of the PI stream was the Portals STRIDE review. Now, the Portals is going to be used as a one-stop shop to access a number of services within the Mojaloop hub from the DFSP side of things. And here we were able to look at how the application will be sitting, the various modules within the application. Sorry, and our recommendations here at high level, if you could just move on. From the diagram here, we proposed that the design make sure they focus on the defense in-depth approach, where we would have some exposed services sitting within the DMZ, preferably exposing them through a reverse proxy or a web application firewall. Again, these are standard recommendations from a data protection standpoint. And then over and above that, there is the issue of designing federation policies, because the Portals application will rely on the DFSPs having ability to create their own users. So the hub will only create an administrator user within the DFSP who will have the responsibility of creating the DFSP side users and assigning them appropriate rights. Now, this needs to be translated back to an identity management solution that will be integrated with Mojaloop. So further research needs to be done on supported solutions and possible high-level policies that can be developed around that from a design perspective. Over and above that, we were also recommending issues around 4 eyes principle, ensuring that the Portals application has maker checker, and audit logging has to be a standard from the word go. And this will be highlighted later on as we look at the logging design. Next.
I think, Victor, let's, just for the sake of time, I think let's keep the logging standards and just shoot straight to next section.
Okay, that's okay.
We have it as part of the presentation deck because we've got quite a bit to cover, and we don't want to go too much over time.
No problem. Thank you so much.
Thank you, Victor. I think Max will be over to you.
Afternoon, everybody. I'm Max Giese. I've been involved in Mojaloop for about 18 months now, starting off on helping on the coil side with the adapters into the payment systems, and then afterwards moving into the more security side, trying to implement the standards into security. The first slide I'm going to show you is one I showed at the last convening, where it is the high level design, what we're going to do for the cryptographic modules. And then, why isn't it moving? And then so that what was agreed. And then I'm going to go on to what we have done for this PI, where, wrong way. Sorry, it's technical. Slow. Okay, and what we are looking at doing in phase 1 of the cryptographic processing module, we are splitting it up into various phases just so we can start getting something in as soon as possible. We have designed this in such a way that we can just implement the functions as they become available. And by doing this, we can quite easily do concurrent development without anyone being dependent on anyone else. As you can probably see here, different from the high level, although we've got a hardware security module software, we have changed the original key management system for a key update interface. This is partly because the key management interface is a lot more complicated, and not all organizations will actually have access to a full-blown key management interface that actually will support the KMIP standard. So what we've actually tried to do is put in a key update adapter, which will be fairly basic. You will add, update, or delete keys. It won't accept any any commands from the cryptographic asking for new keys. It is a very basic one that anyone will be able to implement once we expose the full API. So there are the modules we are going to implement. Of course, we've got to implement the cryptographic processing module. This is the heart and the brains of the system. It will control who does what and how via configuration. As I said, this is going to be done in such a way that once the cryptographic processing module is in, we can basically change anything we'd like in the system without bringing down the system itself. It's only if we do a major change to the cryptographic side, processing side, that we would actually have to stop and start it. The command adapter will allow us to have use of commands to try and run the system, and this will be to approved operators. It's things like shut down, start up, refresh the system's config, refresh its keys if there's been some changes made to the key database, and just to get a status of how your system is going. It's wonderful to have your system up and running, but if you don't know what the status is, if you don't even know that it's running, it might as well not be running. So we're trying to make this as simple and easy to use and to monitor as possible. The key update adapter, as I said, will allow organizations to add, update, or delete keys and or certificates as it needs. Be a very simple interface that anyone can implement from a very tiny organization who might only have 3 or 4 certificates, all the way up to a big organization which would have hundreds. In terms of trying to keep the costs down for some of the smaller operators and for people who are going to be purely running the module loop as it is on its own, we are going to do a software security module where all the security needed will be done in software as it is defined in the current encryption documents for module loop. Most of your security will be able to be done here, and we will be quite strict as we go forward as to what can be done in the software security side, because once you start interfacing with systems like what we're calling the legacy payment systems, who are quite well regulated by PCI, especially PCI HSM and PCI DSS, a lot of the stuff won't be allowed to be executed under software, otherwise that could interfere with their PCI status. And a small organization who's only got a couple of thousand wallets, who isn't big, they need to keep this down to a very low cost. And by implementing the software security module, that will help them keep all their costs down. adheres to the current way that merge loop is done for security, but it will be limited as to what it can do. What we're going to do on the hardware security module for phase 1 is we're going to build a very base skeleton adapter, which will link to the CPM. It will link to a hardware module, hardware security module, and do things like health checks. We're only going to do a base security module because just off the top of my head, I can very quickly come up with 6 big vendors worldwide how you interact with the HSM itself is different from one another. So the CPM will react with the security module in a set way, but you could easily have 6 security modules adapters needed for all the different devices out there. And if you start going into some of the areas, some people might wanting to use some of the obscure, far smaller security modules. So we have to be very careful what we actually develop there. What we are actually trying to keep, sorry, wrong screen. There. What we are planning on doing, we have excluded and will be done in subsequent phases, is one of the main things we will be doing is a key management system adapter. This will, in the beginning, be written to the KMIP standard. There are most of your major key management systems out there all adhere to the KMIP standard. Some of your older ones might not. So again, we're just going to have an adapter to do it. So if we come across a key management system, once we've done the initial one, we can always write the input into that adapter from the key management system to suit what that one does. But the internal message will always be the same. And the other reason we have gone for, as I said, for the key update adapter in phase 1 is not all FSPs will have access to one initially. They are expensive if they adhere to the KMIP standard. So we want to try and keep the cost down initially for everybody. So we'll go, as I said, with a key update, and then the next phase we'll look at the full key management system. The other one we're doing is in phase 2 will be a full hardware security adapter. As I said, we're only going to develop the bare skeleton, so it will run, it will talk to a hardware security module, it will perform health checks as necessary. But until we actually have the confirmed use cases, what it's needed for, and the vendor who's going to supply the HSM, we cannot actually develop a full hardware security adapter. Otherwise, we would probably have to go out and develop 15, 20 of them, which might never get used in the next 5 years. Next one is what we're going to be carrying on with in the future. Now, next steps very soon after this, probably next week or the week after, is we will start planning the development of phase 1, work out when we can try and get at least a basis of the CPM up and running, so that hopefully by the next PI we can probably have it up and running and demoed. And then start with discussions with other players on any new use cases that may be needed for to bring into the security. The ones that we have that were decided on in the last PI was the creation and verification of signatures and the encryption and decryption of any data that's needed. We will just see how things go in the next PI as we go, and we hopefully come up with new use cases. And we're also going to plan the integration of the CPM with other adapters, like the already written ISO 8583, which has been demoed before, to interface ATM and POS devices with the modular system to bring the security into there. And with that, there will be definitely new use cases that we will have to bring in to complete that integration. And then we'll see, as the ISO 20022 adapters carry on, we'll see if there's how we can integrate those with the CPM to ensure that the system is still secure, complete from end to end. And that may also bring up new adapters, new use cases as needed. That is my side. Godfrey, back to you.
Thank you, Max. I think, Simeon, we're way over time. If there's any other question, we can move to the next phase. Thank you.